Bismillahirrahmanirrahim and Assalamu alaikum. I welcome you all to the lecture number 16 of electric circuit analysis. Today we are going to study about inductors, what inductors are, what is their purpose in any electric circuit, and how do they perform their specific purpose. So you might have studied inductors in physics earlier and in intermediate level chemistry and physics. An inductor is a passive element. That means it consumes energy. It is not a producer of energy. However, it can store energy in its magnetic field, and it consists of a coil. The coil is made of a conducting wire, and when current flows through it, voltage appear across the inductor. Inductors are used basically in transformers, radios, TVs, power supplies, and electric motors. Voltage of an inductor is given as L into the derivative of the current. That is, when current flows through it and it is changing, it produces a voltage across the it creates a magnetic field, and a voltage appears across the electric coil through which it is flowing. L is the value of the inductance, and its unit is Henry. So current voltage relationship can be given as V is equal to L di by dt. Now di by dt is, I take L to the other side. Here it is being multiplied, over here it will be definitely divided. So di is 1 over L V dt. If I want to find the value of I have to take the antiderivative of this equation. Integrating both sides, we get to know that with limits from minus infinity to the specified time t, we get this equation. Now simplifying it, I get to know that t naught to t from, and then I current stored at t naught. Normally we take current stored as 0 because we don't expect any stored current in the inductor. Power delivered into an inductor is P is equal to VI, which is by putting the value of V L di by dt into I. And if I want to find the energy stored in the inductor, it can be found out by taking the by integrating the power value, which by formula has the same limits. So by simply inserting in the value, d tau by d tau cancels out each other, and inserting it in the limits of integration, we get to know that this is W is equal to half Li square. As already defined, I minus infinity is 0, so this is how our equation sums up to be. Now note that voltage of an inductor in a DC, when a constant current is being provided, it is always 0 because an inductor is replaced by a short circuit. So in the case of a direct current, capacitor is open circuit, however an inductor is short circuited. This means that the current across an inductor cannot change instantaneously. This means slowly the current flows and then developed at a certain level. You cannot instantaneously change the current across an inductor. Now we'll move on to performing example number 6.8. Here we have a 0.1 Henry inductor. The current value is given. We have to find the voltage across this inductor and the energy stored in this inductor. As you know that V is equal to L di by dt. By inserting it the value of I and inductance, we get this equation. Now we'll take the constant out from the derivative, and we are left with this. Now this is a product of two terms t and exponential raised to power minus 5t. We'll apply product rule of derivation over here, and by simple mathematics and basic steps, we get to know that this equation simplifies to each and every step has been done for you. I hope there won't be any confusion here. E raised to power minus 5t, I took it as a common term because it appears in both of the terms, and here we have left with 1 minus 5t volts. Now energy stored is 1 by 2 Li square. By inserting in the value of I, which was given in the question, we get to know the energy stored is W is equal to 5t square e raised to power minus 10t joules. Unit of energy is joules. Now moving on to practice 6.8, which is quite similar to this. We are given the value of inductance, we are given the current value, and same as before, we have to find the terminal voltage across this inductor and the energy stored in the inductor. We insert in the given values, and it was millihenry, so I used 1 millihenry. Milli is 10 raised to power minus 3. Over here it was also milliampere, so instead of milli we write 10 raised to power minus 3. and this is how, by simply inserting in the values and taking the constant out from the derivative. Derivative of cos is minus sign with the same angle, and then we take the derivative of the angle. This milli, I take it over here and it becomes millivolt. Now dt by dt, it cancels out each other one, and we get to know that the voltage value is minus 6 sine 100t millivolt. The energy stored is 1 by 2 Li square. I insert in the value of I n this, and I get to know that the energy stored is 1.8 cos square 100t microjoules. So there are some questions in the exercise of chapter number 6, that is section 6.4, have some questions, problems related to this topic. Please try to attempt those questions, and in case you have any problem in solving them, do let me know in the question answer section. Thank you very much. Take care. Allah Hafiz.